Chapter 9, Lesson 3, Special Products and Polynomials. So, a couple of these are kind of fun. They're just very quick once you get them. This one here is called the perfect square trinomial. And what it is it's the same statement, in this case a plus b or a minus b, and it's squared. And it's going to get this lovely pattern that's very straightforward. So if you look here, what's going to happen is you're going to end up with x squared plus 6x plus 9. And what I mean when I say that is it's the key to understanding it is right there. It's a squared plus 2ab plus b squared. And so if you look here, the term a would be the x. So x squared is that first term right there. And then 2 times a times b, so it's going to be x times 3 times 2, so that's where we get our 6x from. And then, so that's that part, and then the b squared is right there. So let's do a couple more quickly. And for example, this one right here, so it's going to be, would be x plus 9 times x plus 9 is what it would be. And it just works out that x times x is x squared, and then when we do this pattern thing, it's going to be plus 18x plus 81, because it's just 2 of the x, that's your x plus 9. It's just going to be x times 9 times 2. That's where you get that term. That's the one that tends to be the one that kids are most stuck on. But that's just 2 times x times 9. Because if you think about it logically, you're going to add that once for when you multiply those two together, and then once when you multiply those two together. So that's where you end up with 9x and 9x. So it's going to end up being a total of 18x. So it is the FOIL method, but it's just a quick, easy way of doing it once you see the pattern. So for example, this one right here, 7x squared plus 2 is that whole statement squared. So it's just going to be 49x squared, because that's the 7x squared part. Then it's going to be 7x times 2 times 2. So that's going to end up being plus 28x, and then it's going to be plus 4, because that's the 2 squared. Let's look at a subtraction one just to show you that it works for that too. Same thing here. It's going to be 6x squared, so that's that whole statement squared, so it's going to be 36x squared. Then it's going to be 6x times 5 at y. And when I multiply those two together, I'm going to end up with 30xy. But I have to double that, so it's going to be 60xy. And then the rest of it's going to be adding, because it's going to be negative 5y times negative 5y, 25y squared. Let's look at one more like that. So this is just going to be 2x squared, so that whole statement squared, so that's going to be 4x squared. And then it's going to be 2x times 3, so that's 6 times 2, or 6x times 2, and then that's going to be 12x. And actually, I just made a mistake here. It's going to be subtraction, because see that statement there? It's a subtraction problem. And then it's going to be plus, because it's going to be negative 3 times negative 3, so that's going to be 9. So make sure to keep track of that subtraction piece, because here, definitely you're going to end up with answers that are incorrect unless you pay attention to whether they're addition or subtraction problems. Because here, the key thing is for subtraction, you're going to end up with subtraction of the second term, but it's addition for both the first and third term. So one more time here, this is going to be 100x squared. It's not going to be plus, it's going to be subtraction. So it's going to be 10x times 3y. So that's going to be 30xy, that times 2, so 60xy, and it's going to be plus 9y squared. So let's look. There's another pattern here, and this is the sum and difference pattern. And it's when you have a statement like this. In this case here, it's x plus 9 and then x minus 9. And what ends up happening is that the terms cancel each other out. I want to show you how that works here. For this one right here, if we use the FOIL method, we're going to end up with x squared. Then we're going to do the outer part, so we're going to multiply this x times this negative 9, so it's going to be minus 9x. Then we're going to do the inner part, so we're going to do this part here. We're going to end up with plus 9x. Then we're going to end up with the last part, it's going to be plus 81. So these two cancel each other out, so you're just left with x squared plus 81. And these ones here are actually even quicker and easier than the last ones. So, but if you've got to notice the pattern really clearly here. So, for example, this one here, it's they're going to cancel out just like these ones down here. So it's just going to be x. In this case here, it's going to be the first term squared and the last subtracting the last term squared. So that's going to be actually 16x squared minus 9. That's it. For this one here, it's going to be 49x squared minus 1. For this one here, it's going to be x squared minus 9. This one here, it's going to be 16x squared minus y squared. So again, I hope you get to see the pattern here. It's just this idea of when you have it like that, it only works that way when you have one part that's a sum and one part that's a difference with the exact same statement. So one more here. This is going to be 4x squared minus 81. And you can see the example of why that works down here. So let's look at this. So we're going to move on here. Here's an example of something you guys were talking about. Punnett squares, not Putin squares. But in this case here, it shows dog's ears. And apparently there's a gene E that if you have a capital E, then it ends up with pointy ears or erect ears. And then if it's a lowercase e, then you droopy ears. So if you look here, if you do the Punnett square here, what ends up happening is that this one here, are they going to end up with droopy ears or erect ears? Well, capital E means that it's a dominant trait. So in that case here, you're going to end up with 3 dogs who have, if we have 4 dogs and each of them represent a square, you're going to end up with 3 dogs that have erect ears and 1 dog here, this one here, that has droopy ears. And we will go over in class a little bit more to have a discussion about how you could use polynomial to model this gene combination. So really the important thing is to understand is that for the lesson you've got these 2 specific binomial patterns, and when you go ahead and you multiply them out, you're going to either end up with a squared plus or minus 2ab, and then that's going to be plus b squared. Either that or you're going to end up with a squared minus b squared. Those are the 2 patterns that we're talking about. And that's it.